tool suite lets us build a processor, not just optimized for one thing, but lots of flexibility. We already added new data types for AI, which is going to make performance better. And then we're going to build AI processors and CPUs together in the same silicon where they can talk. And there's 2 papers recently, one from Microsoft, one from Google, which talked about how AI and general purpose computing talk together. This is really exciting, and I think we're going to learn a lot on this. The other thing Moore's Law does for us is unlocks the ability to build the next computer, right? When you had a few transistors, you couldn't build even a pipeline computer. But as we got more transistors, the number of transistors per processor goes up. The first machine I worked on was a VAX-800. It had about 100,000 transistors in it. Modern CPUs, 100 million is a common number. So we have pipeline out of order, GPU shaders where you could run a program on every pixel. And then multi-core processors, when I first proposed K8 at AMD, we're going to do 2 and 4 processors on a die. People thought that was crazy. They're so big. And would you rather have a bigger processor? Now we think 64 is a plausible number. We're just hitting the number of transistors to unlock AI. Jeff Dean gave a talk last year at DAC that was brilliant. And he said when they first got AI algorithms to work, they thought if they could get from 1 to 64 processors, they could really run it faster. And then they realized it was running 1 million times too slow. 1 million times too slow. So modern big language models run on thousands of GPUs for a month to train it. They're still 1 million times too slow, but they're now fast enough to actually do that, and the innovation in space can be really big. We made this slide when we raised money, and I've told people, quoting Andre Garpathy, when you're raising money is a really good idea. So any startup people here, follow him, quote him. But what he said, this is really great. Software 1.0 is when people write programs. They write essentially the way you think. Do this, then do this, if this, do that, right? And software 2.0 is actually take data and information to train a network to make an association. The programs are very, very different. And then I'm not really an AI person. You know, I'm a CTO of an AI company, and for the last year I've been reading a couple papers a week. And I noticed they all write in high-level math, which I vaguely understand from 40 years ago. But the good news is the AI researchers are pushing the envelope of the math to describe the relationships between data. But that translates into simple equations that computer guys like myself know how to speed up. A equal B times C plus D. I'm not kidding you. Almost all the hard math turns into something like that. This math has established the understanding about what the data is doing, but the AI programs themselves are actually kind of small. Hundreds of lines of codes to do a model that runs in thousands of GPUs for a month. The programs make a graph, and then our job as an AI company is to translate that graph. So we did the same sequence of events, which is take the architecture stack, and then we translated that into a complicated software stack. So PyTorch and TensorFlow are open source languages for AI. TVM is an intermediate representation which we use. Then we generated something that expands the graph, puts in autograd, lowers the graph, and then finally places that on a large array of processors. And our innovation is you can write the graphs you want, and we can run that automatically. And then we paired that up with simulators so we can simulate at each level and understand it. And here's an example of what graphs mean. So AI is built on a small number of primitives, but when the programmers write the code, there's a huge number of different graphs, and this turns it into a really hard problem. Our founder Luigi said when he started working on it, he knew it was hard, but then we found out it was way harder than that, because the combinational complexity from a small number of operators and a small number of graph operations turns into a huge variety of code. The way our computer works is you write code on the left. That's part of BERT, which is a popular language model. We translate that into a graph, and then we lower that into multiple processors, and then we lay that out on large numbers of AI processors. Our chips have about, shameless plug for Tenstorrent, 100 processors or so in the first generation. We can hook up thousands of those together. So this is an amazing thing. One program through a compiler to go engage 1,000 processors. We're building this today. The first 2 generations is a partnership with a company called Invicus. We designed the AI hardware. They did the back end. Their execution was flawless. This is a beautiful thing in the modern age. Our chips powered up and ran the first time. Right. We've integrated in RISC-V processors. We're starting to use AI to build AI, and there's a picture of our CPU team that we just started hiring in Bangalore. It's really exciting what's going to happen next. Here's a picture of some computers. It's kind of wild with all this change underneath. We're building a 4U server with 8 PCI Express slots, 2 chips on each one. That's the first version. The second version on the left is an AI data center with 2,000 processors in it. We built the first one in Austin. We're now pursuing a plan to try to build the next one here in Bangalore. We started hiring open source software people, open stack software people. Some of them are right here in Bangalore. This is going to be the next really big step for us. I just want to circle back to the other component of winning. You have to own the goal. One of the big transformations I did when I led teams here is don't treat the resources as resources. Figure out how to give the right size project to the team with local ownership. And what I love working in India is the skills are there, the attitude is there. They really love the ownership and they'll kill themselves for it. And the intensity is super great. Next one is the goal is great products, not huge teams. I've listened with some concern to some of my friends here about the teams growing really fast, and they're doing 6 different things. More people should turn into more teams that are great. Right? And there's so many things to make better. Like our modern CAD tools are really good. I think there's another 10x. Right? And we start to use AI for CAD tools, it's going to change things. And then all the leaders have to think, this world is changing really fast. How do we set up to succeed so that our engineers get the right training, they get the right opportunities, and they get the right ownership? And I saw the trains are starting to run in Bangalore. I've been watching those being built for 10 years. It's actually affecting our decision about where to locate our office because I want that team to be able to get to work quickly, in a clean, safe way. All right. India has really great people. I used to hear, great people, but we don't have the leadership, and that's over. There's plenty of great leadership here. Right? You have the experience to lead. The skill requirements are going to be changing really fast. Look at everybody, I just ask you to look at your teams, make sure it's not all 1,000 people turning the crank on the old design doing somebody else's stuff. That will not get you to a leadership position. Really have to think about that hard. And then leadership requires working in new areas. RISC-V is going to be really big. It's going to innovate faster than any other architecture because it's open. That's what happens with software all the time. That's what happened with AI software. Researchers do new models, they publish it, and everybody does it. This is going to be a really big change. And AI itself is a fundamentally different kind of computing than general purpose processors. I worked at Apple, and I didn't work for Steve Jobs. I worked for a guy who talked to him every day. We always knew what Steve thought, very fast. He was very direct. And that helped me understand what directness means. Sometimes it's hard, but being direct and winning is so much better than beating around the bush and losing. He said, why screw up 2 things when you can only get 1 thing right? It's a beautiful thing. And then focus on doing the best thing you can. And once you know what that is, only do that. I had a lot of fun this week talking to students. The intensity of wanting to do and know is super great. I think there is a real opportunity for India to lead. And thank you. Yeah. So I didn't know if we'd negotiated Q&A. Is there any questions anybody wants to ask while we're...
Yeah, since we have some time, we can take a couple of questions, but then sincere request to all of you to kindly ask the questions straight away without any preludes, please. The mic will come to you and you can ask your question. You can just raise your hand, the mic will come to you. Yeah. Ilbani.
Right.
Yes, sir, the mic is come to you.
With me, what has been the influence of meeting with Swamiji and, how has that inspired you?
Well, the question was I just met him yesterday. It was a unique opportunity. And as we were leaving, somebody introduced me as Jim, the computer architect. And he said, "You're making things faster. That's very good." And then he talked to me for 30 or 40 minutes. I mostly listened. I'm still processing. I told him I would mention the bumblebee story, because it's the perfect story about how do you take a little from each place and then make the best contribution, which I think is really great. And bringing everybody together with technology, like we need to do that to make the world safe. I'm in India partly because I think it's really great when we have great people everywhere working together to know each other. Like one time I did a flight from London to South Korea, and I flew over the Soviet Union and China, the two countries I was terrified of as a little kid. And it was like changed the world. And I'd heard so much about India and what was going on when I first came here. It was so heartwarming to meet real people and work with them and then understand them, good and bad, and then make a contribution. I think that's really important. Is there another question? There we go.
Thanks for the great innovation, technical presentation also. So one of the questions you mentioned that one of the potential areas for India to focus would be RISC-V. Of course, India has great IT talent or coding talent, design talent. So it's easy to merge those two and start a foundation, but it goes beyond that. It says making products out of it, then possibly a manufacturing setup, and also making commercializing those products. So what do you think are the biggest gaps India has to fill, the talents that doesn't exist today in the next, say, 5 to 10 years in RISC-V?
Yes, so the question is, are there gaps in the technology to build like the next generation CPU ecosystem? And I actually think there's not very many gaps. It's really the determination to do it, right? You say, this is a technology where people here can innovate and do new things, right? And then what happens with that kind of platform, it finds its way into all kinds of new products. And then those new products go impact the next generation design. And it goes from server room to mobile right now is kind of locked up with a small number of players. If you want to do a new open mobile platform, you have to go build it on a new technology base, right? And then the other thing, and this is a secret, but I'll tell you guys, because I heard there's 5,000 people online, but AI is going to start to write code. That code is going to be much more complicated than the current code people write. That's going to then impact how we build general purpose processors. And the people who are involved in using AI to build computers, to write code, and then build that are going to win. And the talk here today was about how to lead. And to lead, you have to win. So I think it's a real opportunity. The skills and talents are here.
Hi, Jim. So you talked about that we have been working for 40 years in making C program run faster, and that translates to von Neumann typical architecture, right? So now in your new venture, you are using both traditional and AI, right? So how the AI ML silicon has opened the new vistas for new architecture, because we can now break out of the von Neumann and basically have multiple different architectures, whether it's a systolic, whether it's basically multiprocessor, in-memory computing. So how do you see the whole architecture space open up because of the AI/ML?
Yeah, so how will AI change computer architecture? So there's going to be, we're in the experimentation phase. There's 50 AI startups, right? When GPUs first came out, there was 50 GPUs, only a few won. But actually, many startups made valuable contributions. And some of those were acquired or their ideas were copied. Like Raj's here, he worked at S3 and then ATI. Like you see the startups do the exploration, and then there's a consolidation phase, right? And a maturity phase. Network processing the same way, networking the same way. Right? This has happened many times. AI, people say, oh, there's so many startups, isn't that bad? No, that's how we go explore the space. Now, the other interesting thing is processors today do what you tell them to, and we treat AI as an accelerator. Now, imagine the human brain. You have a motor cortex, a sensory cortex, right, and a cerebral cortex, right? When animals were simple, you ran on what to do, what do you want, where to go, right? And we started building a cerebral cortex, evolution, or somebody did, right, which actually is an abstract planning system. And at some point, that system took over, at least for most people. Right? So today, right, it's true, most people, not everybody figures that out, right? Today, AI is an accelerator to a big computing infrastructure. The future, that computing infrastructure will be in service to the AI programs that we use to run our world. And that transformation is already starting. Read the Pathways papers, read the Singularity paper. And the computers we built for that are very different from a server with an attached accelerator. And when you see that kind of transformation that big, then you say, let's make sure we're doing lots of experiments and projects on the new stuff, not 52 little derivative projects on the old stuff, which again is what I came here to talk about. One last question, and then...
Yeah, the next question is, thank you, Jim. So we see that the RISC-V is rapidly shaping the world right now. It's actually revolutionizing the semiconductor industry very rapidly. What do you think are the succeeding factors, and how do you compare it with ARM?
Yeah, well, I told the one story already. I love my friends at ARM. I asked them for a change, and they said, no, we don't see the need. Well, who am I? I thought I had a need, right? The students can do it. You can download from a number of different, there's the Shakti core, Boom core, Rocket core. They're pretty good. The students can then go do experiments. My team supports the open source RISC-V reference model. We added tracing capability, and we're going to publish some new extensions so people can use that and play with it. More people doing it opens up innovation. And then, this is an interesting thing, the speed is really important. If you want to go faster than somebody else, if you want to beat them, you have to move fast. And many experiments actually accelerate speed. It's not centralized, it'll be a little messy. That's right up India's alley. So it'll be great. Okay. Thank you very much, everybody.
Thank you very much, Mr. Jim. We'll now take a break, and now a little bit of opportunity for all of us to go through the stalls. So feel free. So we'll have some time to, if you have any queries, do not forget to visit the stalls, and thereafter have lunch and do come back by 2 p.m. We will be restarting the session in the afternoon, 2 p.m. So we'll have about 10-15 minutes now to go around the stalls. Hope you enjoyed the sessions in the morning. Namaskara, and all of you take care. Have a great lunch.